Hello friends, welcome to my YouTube channel Physics Cafe by Manjeet Kaur. In this video, we study about class 9th physics chapter sound. So friends, today's our topic is reflection of sound. So before we study about reflection of sound, we will discuss reflection of light. So friends, what is reflection of light? The bouncing back of light when it strikes through a plane mirror is called reflection of light, in which we have two angles, angle of incidence and angle of reflection. And the angle of incidence is equals to angle of reflection. So just like the reflection of light, we have reflection of sound. When sound travels in a given medium, it strikes the surface of another medium and bouncing back in some other direction. This phenomena is called reflection of sound. And the waves are called incident wave and another is reflected sound wave. Here we have example. Sound produced by observer comes in this direction and strikes through this hard surface and bouncing back in this direction. So when sound travel in this medium and strike this surface and then reflected back in another direction is called reflection of sound. And this wave which comes from the observer is called incidence wave and which wave is reflected back is called reflected wave. So to understand this in detail, we take an example. Here we have example in which this is the hard surface and this is the sound comes from the observer, and when it strikes through this hard surface it bouncing back in this direction. And this wave which comes from the observer is called incident wave, and this wave which it reflected through in this direction is called reflected wave. And this is the normal and this is the angle of incidence and this is the angle of reflection. And this is the hard surface. So the bouncing back of sound when it strikes through the hard surface is called reflection of sound, in which angle of incidence is equals to angle of reflection. And one more thing, the angle of incidence, the angle of reflection and normal all lie in one plane. So this is the example of reflection of sound. Now the two laws concerned with sound reflection are as follows. The incidence angle will always be equal to the reflection angle, and the incidence sound wave, the normal and incident point and the reflected wave all rest in a common plane. That means all lie in one plane. Here this is the light which comes from the observer That light which comes from the observer is called incidence wave. And when this light bouncing back in this direction is called reflected wave. And this is the angle of incidence which make with the normal, and this is the angle of reflection which make with the normal. So the bouncing back of sound when it strikes this hard surface is called reflection of sound. And these are the two laws of reflection of sound. Now we have uses of reflection of sound. Reflection of sound is used in many devices. For example, echo, stethoscope, soundboard, loudspeaker, megaphone, and hearing aid. So now we discuss all these in detail. First we have echo. It is the sound heard when reflections occur from a firm surface. This surface may be wall, a cliff, and many other. That means echo is that sound जब आप किसी भी पहाड़ी पे जाते हो, किसी अकेले रूम में हो और अपना नेम जोर से चिल्ला रहे हो, देन जब आप चुप हो जाते हो आपको वही आवाज़ फिर से सुनाई देती है. That sound is echo. So echo is the repetitions of sound even after the source has stopped vibrating. That means जब अपना नेम लेने के बाद चुप कर जाते हो आपको वही आवाज़ फिर से कानों में पड़ती है. That sound is echo. Thus repetitions of sound occur because of multiple reflections of sound wave. Here we have diagram. In this is the sensor and this is the target. So from sensor, sound wave is produced, and when it strikes through this target, it bounces back. So that sound is echo. And echo is used by bats as well as dolphins for the detection of obstacles. Now we have stethoscope. It is used to hear the sounds of internal organs of a patient for diagnostic purposes, which works on the law of reflection of sound. In this, sound is received by chest piece. This is the chest piece, and sent to the earth by multiple reflections through a long tube. To understand this, let's take an example. It consists of long tube, this one, which made up of rubber and metal. When sound pulses pass through from one end to the tube, the pulse is concentrated to other end due to several reflections in the inner surface of the tube. Here, sound pulses pass through one end to another end. So, due to these multiple reflections through a tube, sound is heard through the earth pieces. And the next is soundboard. It is used to send the sound towards audience in big hall or auditorium. It is a big concave board. That soundboard works on the basis of reflection of sound. soundboard is set in such manner behind the stage that speakers is at the focus here. So sound coming from the speaker falls over soundboard and get reflected towards the audience. Due to this large gap between the audience and the stage, audience can hear everything very clearly because of soundboard. This is the diagram of soundboard. And the next is loudspeaker. It is used to send the sound in a desired direction without spreading the sound all around. That means इसका यूज हम साउंड को एक पर्टिकुलर डायरेक्शन में सेंड करने के लिए करते हैं. It acts on the laws of reflection of sound wave. In this, a funnel-like cone-shaped tube is used like this. Sound is introduced at this narrow end of the tube. This is the narrow end. And sound is to come from its wire end. So here we have diagram. This is the funnel-like cone-shaped tube, and sound is introduced this narrow end, and sound come out from this wider end. Next is megaphones. Megaphones are horn-shaped tubes that prevent the spreading out of sound wave. That means it's not spread the waves in all directions. Waves of sound are spread in a particular direction by successive reflections, thus confining them to the air in the tube. So a cone-shaped device for magnifying the voice used in addressing a large audience or crowd out of doors or calling to someone at a distance. That means मेगाफोन का यूज हम क्राउडी एरियाज पे करते हैं जब हमने किसी पर्टिकुलर पर्सन को बुलाना हो. The next is hearing aid. Hearing aid is a device used by people with difficulty in hearing. That means hearing aid का हम वहाँ पे यूज़ करते हैं दिस डिवाइस का उन लोगों के लिए जिन लोगों को सुनने में प्रॉब्लम होती है, जिन्हें कम सुनाई देता है. Here the sound waves are received by hearing aid and reflected in a narrow area leading to the ear. Next we have reverberation. To understand this, first we understand this diagram. This is the auditorium in which sound is produced. Because sound is produced, so due to reflection of sound, echoes are produced. Here sound is go to the listener direct, and here multiple echoes are built up. So these echoes easily decay because they are absorbed by the furniture, people, air, curtain, etc. So it is the phenomena of persistence of sound after it has been stopped. That means it decays gradually as a result of multiple reflection from surfaces such as furniture, people, air, etc. within a closed surface. That means जो साउंड की वजह से इको प्रोड्यूस होती है वो इको ग्रेजुअली डिके हो जाती है। किसकी वजह से? बिकॉज फर्नीचर, पीपल, एयर, कर्टेन उस इको को इजिली एब्जॉर्ब कर लेते हैं। सो दैट इज द reverberation. Next we have example. A person clapped his hands near a cliff and heard the echo after 5 seconds. So what is the distance of the cliff from a person if the speed of the sound is taken 346 meter per second? So given speed of sound, which is v, is equals to 346 meter per second. Time taken for hearing the echo, which is t, is equals to 5 seconds. So distance travelled by the sound, which is equals to velocity time. So put the value of velocity and time, we get 346 meter per second into 5 seconds, which is equals to 1730 meter. So in 5 seconds, sound has to travel twice the distance between the cliff and the person. So distance between the cliff and the person is equals to 1730 meter divided by 2. So we get distance between the cliff and the person is 865 meter. Now we have next example. An echo return in 3 seconds. What is the distance of the reflecting surface from the source given that the speed of sound is 342 meter per second? Given speed of sound is equals to 342 meter per second. Echo returns time, which is equals to 3 seconds. So distance traveled by sound, which is equals to v cross t. So put the value of speed of sound and echo returns in time, we get 342 multiplied by 3, which is equals to 126 meter. We know sound must travel a distance which is twice the distance of reflecting surface and source, which is equals to 126 upon 2. So we get 513 meter. Thus the distance of reflecting surface from the source is 513 meter. Next we have sonar, which full form is sound navigation and ranging. It is a device that uses ultrasonic waves to measure the distance, the direction and the speed of underwater objects. एक ऐसा डिवाइस है जिसमें हम अल्ट्रासोनिक वेव्स को यूज़ करते हैं, किसके लिए? डिस्टेंस पता करने के लिए, डायरेक्शन पता करने के लिए और अंडर वाटर जो ऑब्जेक्ट चलते हैं उनकी स्पीड को मेजर करने के लिए. Now its principle is it uses the phenomena of echoes in determining the sea depth and locating the presence of underwater objects. Here we have diagram. This is the ship, this is the transmitter which transmits the wave, and this is the receiver which receives the wave. So the phenomena of echo is based in this. The sound waves are emitted from the transmitter, then by striking this object it bounces back and come back to the receiver. The receiver receives these waves. So by using this we easily determine the presence of underwater objects and the depth of sea in the sea. The working of sonar. A sound beam of ultrasonic wave is sent from a transistor mounted on the ship. That means जो शिप के नीचे ट्रांसिस्टर लगा होता है उससे हम क्या करते हैं, वेव्स को ट्रांसमिट करते हैं by using ultrasonic waves. Then the beam is reflected from the ship and is received by the underwater detector which is also mounted on the ship. And then जो हमने वेव्स सेंड की है, जो ट्रांसमीटर ने वेव्स कम आउट की है अपने में से, वो वेव्स जो किसी ऑब्जेक्ट के साथ स्ट्राइक करती हैं, here the waves come out from transistor and bouncing back, then reflects these waves. So the time interval between the transmission and reception of the ultrasonic signal is noted. So this is the working of sonar, in which we have two main parts. First is transmitter and another is receiver. Transmitter transmits the wave and receiver receives the ultrasonic waves which come out from the object. Now we have example. A submarine emits a sonar pulse which returns from an underwater cliff is 1.02 seconds if the speed of the sound in salt water is 1531 meter per second. So how far away is the cliff? Given sonar pulse taken time to return is equals to 1.02 seconds. Speed of sound in salt water which is equals to 1531 meter per second. So distance traveled by sonar pulse which is equals to S into T. So put the value of sonar pulse and the speed of sound in this formula. 1531 into 1.02, we get 1561.62 meter, which is the distance traveled by the sonar pulse. So distance of cliff from the submarine is equals to total distance upon time, which is equals to 1561.62 divided by 2. So we get distance of cliff from the submarine is equals to 780.81 meter. Now we have structure of human ear. It has three parts: outer ear, middle ear and inner ear. First is outer ear which collects sound from surrounding. तो क्या करता है, हमारे आसपास से साउंड को कलेक्ट करता है. And the next is middle ear. It amplifies the vibrations. जो वाइब्रेशन को amplified करता है. And the inner ear convert sound into electrical signal. And this is the diagram of human ear which has many parts: pinna, eardrum, ear canal, hammer, anvil, stereo, cochlea, semicircular canal, auditory nerve. So these are the important parts of our ear through which we can hear everything. By using these parts we can hear everything around us. So let's study in detail. First we have pinna. It is the outer ear. It acts like a funnel to send the sound waves inside the ear. That means ये एक funnel की तरह काम करता है. साउंड वेव जहाँ से आती है और इसके अंदर चली जाती है, लाइक दिस, यहाँ से अंदर चली जाती है. ओके, द नेक्स्ट इज ईयर कैनल. Sound travels from the outside through ear canal. That means जो पिन्ना से साउंड आया देन वो ईयर कैनल के थ्रू आगे चला जाता है. देन जो साउंड ईयर कैनल से आया वो ईयर ड्रम से ईयर ड्रम तक पहुंच जाता है. That means the sound then falls on the eardrum which is at the end of the canal. Next we have three important bones of our ear: hammer, anvil and stirrup. These bones, then the sound waves are then passed on to these bones in the middle ear. That means sound waves, by using these bones, sound wave हमारे कानों तक पहुंचती है. Okay, the next is cochlea. The sound waves are converted to electrical signal by using cochlea. Cochlea के थ्रू जो साउंड वेव्स हमारे कानों तक पहुंची है, एंटर हुई है, वो किस में कन्वर्ट हो जाती है? इलेक्ट्रिकल सिग्नल्स में. एंड द नेक्स्ट इज ऑडिटरी नर्व. ऑडिटरी नर्व क्या करती है? सिग्नल्स को हमारे ब्रेन तक पहुंचती है. देन उन सिग्नल्स को हमारा ब्रेन इंटरप्ट करता है एंड देन हाउ वी हियर, देन हम सुन पाते हैं. सो दिस इज द स्ट्रक्चर ऑफ ह्यूमन ईयर. सो आई होप फ्रेंड्स you like my video. So thank you for watching my video. Like my video and subscribe my channel and also share with your friends.